Hey, I'm GamerPatty, and today I got one of these Chinese electronic loads. This is the ET5420 dual channel load, capable of up to 150 volts, up to 20 amps per channel, and a total of 400 watts, so 200 watts per channel. The channels can be programmed independently, and yeah, I got this one off AliExpress. I paid for it for myself. It's not a sponsored video. And for my German viewers, they have a Poland warehouse. It only took a week to arrive, and I don't have to pay any custom fees. From the outside, it's pretty stable metal construction. Front panel is all from plastic, and those banana plugs. Unfortunately, they don't have holes in them for sticking wires into them. But they don't seem too cheap, so no concerns here. So the unit came with a warranty card, quality certificate, and the user manual, and yeah, power cable. And unfortunately, it didn't come with a USB cable, which is not ideal since yeah, that's not a USB host, that's a USB device, so you need a USB male-to-male connector, which is quite unusual. I found one in the USB 3.0 specification used by those PCIe extension things for miners, and yeah, they didn't include one, unfortunately. So let's turn it on. The fan noise is not good, but also not bad. I've heard worse. I've heard much worse. For example, I've used this unit before. It's a Central Electric electronic load. It's only 200 watts, and it's way louder. It's way louder. And it only goes up to 75 volts, so meh. Time to get rid of it. The unit uses a color TFT display. Unfortunately, not an IPS, which, yeah, at certain viewing angles. For example, when I look from it at the top, let's detach the camera. Yeah, I've seen worse before, but it's also not ideal. But for a typical bench setup, you sit right in front of it, so yeah, it does the job. The buttons feel quite nice. Nothing to complain over here. They are rubber buttons, not as squishy as I thought. The encoder wheel is also quite nice. It's better than the ones on the Sigland scopes. They're quite bad. And as I said, the overall construction is quite rigid. Nothing to complain over here. The user interface is not ideal, unfortunately. In the manual, they show it as... where is it? They show it as this one, where you see both channels at the same time, and you see everything. And on this one you only see the channel you've selected. You can select channels by pressing the CH button, and to enter the menu you press Shift and trigger, and from here you can select the menu entries and go into them with Enter. To leave you hit Shift and right, which is labeled Escape. To turn on a load you just hit the according button, and you can also turn on load 2 if you're in the load 1 mode, which is sometimes a bit confusing. And to select the mode you press Shift CH in the main menu, and then you can select between constant current, constant voltage, constant power, constant resistance. That's the usual modes almost every load has. Then you got some special modes like constant current plus constant voltage, constant resistance plus constant voltage, transients, a list of tests where you can insert some tests and it automatically does them. A scan mode, which it increases the load in steps and checks the output voltage. A short circuit test, it just kicks in the 20 amp load instantly and tells you what your power supply is capable of handling. A battery test for discharging batteries and showing the amp hour capacity, and a LED test. More on that later. The LED test is it simulates an LED. You can simulate an LED by the constant resistance mode, but you got a feature in the forward voltage drop, which this mode does. To select the mode, you just press enter. In case you bought one of these models and your text is in Chinese, the way you change it into English, you press Shift Trigger. You scroll to the system set or second entry, hit enter. Scroll to the second entry and hit enter again. In this case I change it to Chinese now. But yeah, that's how you change it to English. And back to the main menu. This unit comes in two modes. The first mode only goes to 3 amps and up to 20 volts. By default it's set in the low mode. To change this, you go to the menu at Shift Trigger, enter load set, and you change the range from low to high. I now change it to low to show you this mode. And the limits is set to 3.1 amps at absolute maximum and 21 volts at absolute maximum. And you can't go higher than this. Let's try to go 4 amps. Nope, not even 3.1. Nope, nothing. To change it back, you go to the menu and change this back to high again. There we go. Now you can change it to 20 amps, but you lose some of the resolution, which is not bad. I mean, this doesn't have sensing wires, so you won't get any good resolution anyways. At a 20 amp load, I had with some good cables, like half a volt up to a 1 volt drop on the cable, so you better use a multimeter for accurate measuring. You can also set a shut-off time by selecting the off time, hit enter, and let's say 2 seconds, enter, and when you turn on channel 1 it turns off after 2 seconds. There we go. And it reverts the setting back to off. On the front you got a PS2 interface. You can hook up a PS2 numpad if you like, or rig something up with an Arduino that emulates a numpad or input method if you don't like the rotating knob. Because I found an issue with the firmware, which is if you enter this mode you always land on the last digit. It's quite annoying. You have to click to the left to change the tenths, and if you hit enter it applies the value, and if you hit enter again it lands on the right side again. It's quite annoying. If you're in the low power mode it's even more annoying, because you can set in 1 milliamp steps and you always get to scroll to the left, and if you hit enter again it always lands on the most left side. It's not ideal. I wish they had some remember function for this. Okay, we are over at the bench. Let's turn them on and let's test the electronic load. That's a ET5420 and I've hooked it up to an actual 1000 watt power supply, so I can in theory deliver 1000 watts, but this is just a 400 watt load and I can only put 200 watts per channel in, so let's only go to 200 watts. Let's see, let's set it to 10 volts at a current limit of 20 amps. And you see it's 10.02 volts, so let's turn it on at 1.1 amps. Yeah, 1.1 amps. Let's increase this to like 10 amps. It increases before you even press enter, so yeah. That's 100 watts, 9.7 volts, 9.99, so we got a slight voltage drop. That's the unfortunate bit if you don't have a sensing wire. Let's increase it to 20 amps. There we got 182 watts. Let's increase it a bit further to reach 200. Slightly above. Its power limit is 220 watts, but you shouldn't go there for long periods of time. It's really just a 200 watt load, so yeah, channel 1 is working. Let's turn it off and hook it up to channel 2. Channel 2, enter. We are under low power mode. As I said, you can't go above 3 amps. And let's turn it on. Yeah, it's 30 watts. That's alright. 3 amps, 2.99, so yeah, 3 amps. Let's turn it off. And go to the high power mode. There we go. Turn it back on and change it to 20 amps. There we go. 200 watts. Alright, so let's increase the voltage to 50 volts and see how it handles this. I can go up to 4 amps to reach my 200 watts in this case. So I go to 4 amps. And increase my voltage to 50 volts. There we go. And let's turn it on. Yeah, 200 watts. Turn it off. So, let's hook up the second channel. This weird fucker is a DPS 5015 hooked to a 1000 watt power supply. It theoretically delivers 750 watts. So, no problems there. Let's turn it on. It's quite noisy, I don't use it that often. Let's hook it up. And since this is only capable of 15 amps, I won't go to the full 20 amp range, so let's say I first increase the current limit to the maximum, so this won't bog down, and set it to, let's say, 20 volts. So I need 10 amps to reach my 200. There we go. Turn it on. 20 volts. Let's also set this to 20 volts. There we go. Both 20 volts. Change the amperage to 10 amps on both channels. There we go. And now you can turn on both channels at the same time by pressing both buttons. You don't need to switch the channel. It's not good, but it's also not bad, so yeah. Let's turn this one on, channel 1. It's drawing 200 watts, channel 2. It's also drawing about 200 watts. I attached a very long lead to this, so it's not quite 200 watts, so yeah. But it does the job. It's 400 watts now, almost. There's nothing else to say, really. Let's go to the full. Yeah, that's 240 watts, 230. That's alright. Let's turn it back off. There we go. And let's disconnect channel 2. This is quite noisy, I don't like it. Now that the power tests are done and I turned off all the noisy equipment, let's go to the fine stuff. I've got a 0-volt power supply over there. It's quite a bit more accurate than the other ones I have. And yes, let's hook it up and see what's the minimum range of this load is. I'll set it to 1 amp. There we go. And my source to, let's say 5 volts. Alright. Now let's turn it on. And I've set channel 2. That's the problem if you only see one channel at a time. It's really confusing. So let's set this to 1 amp. Turn it on. And yeah, it's bang on, 1 amp. Let's decrease it to like 100 milliamps. Yeah, it's 104 milliamps. That's all right. It's the high power mode. Don't forget that. Let's go to 10 milliamps. 17, not ideal. Let's switch it to the high power mode. Oh yeah, also you can't enter the load set menu if you have your load turned on. Right. Gotta first turn it off. Go to the load set menu and let's change the current range to low. I could also change the voltage range to low. The current range, high and low, means you can either dissipate 3 amps or 20 amps at a low resolution, or like the 3 amps at a high resolution. And the voltage range, you can either use up to 20 amps at a high resolution, or up to 100 at 20 volts, or up to 150 volts at a lower resolution. So let's select the high resolution mode, which is actually low, so it's the no, you know what I mean. Let's go down to 1 milliamp. There we go, and turn it on. It's showing 2 milliamps. It's within the usable range, and I certainly will be able to detect it via this clamp meter anyway. So 0. That's 17 milliamps. Yeah, really, clamp meter is not made for these low ranges. But yeah, I mean, it does the job. Let's increase it back to 100 milliamps. There we go. And let's compare the voltage. I know this is quite accurate. I've measured on my Unity ET5420, I think. It was bang on, so yeah, shouldn't be a problem. Let's go to 30 volts. And you see channel 1 over voltage protection. That's because in the low power mode, it disconnects the load if you go above what it's capable. So let's change it back to 10 volts and hit enter. So let's change the mode. The next mode is constant voltage mode. I always click this button, but it doesn't do anything. It tries to maintain a voltage set to, let's say 8 volts. Yeah? It increases the current until it reaches 8 volts, and it will throw me over current error because my current limit is 6 amps. So let's see. Beep. Yeah. Over current. The fan you hear is from the power supply. Let's turn it off and decrease the current limit to like 2 amps. And now it should go to 2 amps. Yeah, it should load the power supply until it reaches the 8 volt set point. Let's see. or a current protection, alright. So the power supply is not quite reacting the way I thought it will. Let's increase it a bit further. 1 amp. Try again. Yeah, we gotta need the high power mode for this. And there we go, come. High power mode, current range high, voltage range you can set to low because we're at 10 volts only. And let's try it again, 8 volts. And there we go, 8 volts at 1 amp. And it tries to maintain the voltage. Now let's turn it off. Go to channel. And the next mode is constant power. It's self-explanatory, 50 watts. Let's increase this back to 6 amps and like 6 amps and 20 volts. Now it should regulate at 2.5 amps automatically to maintain the 50 watts constant power set value. Let's see. Yeah, no problems there. Let's also try the off timer. Let's set it to 2 seconds and turn it on, and you'll see it turned off again. Alright, the next mode is constant resistance. It's also self-explanatory. It tries to mimic a resistor. So if we go to the value and set it to 100 ohms, that means at 1 volt we should have a current flow of 10 milliamps, I guess. Let's change it to 10 volts, that should be 100 milliamps. Yep. And there we go. Yeah, 100 milliamps. No problems there. Let's change it to 10 ohms. No problems there, 1 amp. Yeah, it's working. Why shouldn't it be? I paid for it. Let's go to the next mode. I will skip these constant current, constant voltage, and constant resistance, constant voltage modes. And they are like constant current, constant voltage is like it tries to load the source. And when it reaches a certain voltage, it won't go below that. It just decreases the current on the source. Let's see. Let's say I load it at 2 amps and my lower limit is, let's say, 10 volts. It's like a cutoff point at this thing. And I set my voltage to first to 13 volts. And turn it on. And also the power supply. Why the fuck is it drawing 6 amps? Huh. I've misread this somehow, I think. It turns off below 10 volts and goes to full at 12 volts. Alright, let's try this. No? Maybe it's a bug, maybe I have no idea how to use it actually. Let's turn it back off. The next mode is the transient mode. That's I'm gonna test on the oscilloscope later. The list mode. To change the list, you press Shift and the left arrow and go to this menu. You have the options list test set, list test recall, and list test out. Let's go to the set, and you can set a few tests you want to do. First test is like constant current at 2 amps and a delay of 5 seconds. Yeah, I haven't read into this mode a lot since I won't use it anyway, so. And you can change the menus at the bottom with the arrow keys and the options with the scroll wheel. Let's go back. The next mode is scan mode. Let's turn the power supply back on at 12 volts. And the scan mode will basically sweep a current. You start at a half a amp and end at 3 amps and a step of half an amp. Each second it increases by half an amp. So let's turn it on. Half an amp, 1 amp, 1.5, 2, 2.5. There we go. And you can set up a few parameters like the mode from constant current to constant voltage to constant power, constant, no constant resistance, interesting. You can set the values and the type. I haven't looked up what this does. You can set a forward voltage drop or threshold voltage, and yeah, go back to the main menu and change it to short. It's a short circuit test, and when I turn it on it just tries to kick in the full limit, and if it goes above that limit, well, it reports an overcurrent error, so it just shows me what the short circuit current of my power supply is, which should be 6 amps, so turn it on. Yeah, 6 amps. Now it's changed the mode again to LED. So the LED, as I said, you can use the constant resistance mode for this, but this mode also includes a forward voltage drop. After you reach the forward voltage, then it will kick in the constant resistance mode. Let's set the forward voltage to, let's say, 3 volts. I think it's white LEDs have this, not sure. And a forward current of, 2 amp. Let's turn it on. And we are way above this, obviously. Let's change the voltage to 1 volt. So we are below the forward voltage. Let's increase it to 2 volts. Again, we are coming near the forward voltage. Now the current increases a little bit. And at 3 amp we should have the 2 amp set forward current. It's quite useful if you do a lot with LEDs, like LED strips, and you could design power supplies for it, or maybe even laser diodes, but I'm not sure about the transient response, so it may not be accurate for laser diode drivers, but for LED it should work fine. And the last mode is the battery test. Self-explanatory, and I've set it to the constant resistance mode, which doesn't work. That's unfortunate. And I've set the cutoff voltage to 10 volts. Let's go above 10 volts so it won't cut off. There we go. And I'm on channel 2. Oops. Channel 1. Channel 1. There we go, battery, and let's turn channel 1 on, and now it works. Confusing. Last time I tried it, it didn't work. Well, alright, well, it works. Interesting. Let's change it over the mode menu with shift and left to constant current. You can set 3 different currents that kick in at different threshold voltages. So let's say we discharge this battery at 3 amps up to a threshold voltage of 12 volts. Then we discharge it at 2 amps down to, let's say, 10 volts, yeah. Then 1 amp down to 8 volts, and below 8 volts it should shut off to not over discharge a battery. There we go. Let's increase the voltage to, well, let's say 14 volts. And turn it on. Yeah, it's counting up the capacity. It will reset the capacity if you restart the test. And yeah, it's 3 amps. Let's decrease it down to 12 volts. It switches to 2 amps because, well, I'm a little bit below 12 volts because of the voltage drop of the wires. And let's decrease it further to 10 volts. I'm again below 10 volts due to the voltage drop, and I'm dropped to 1 volt. Let's go to 8 volts. There we go, and the test is over. It turns off and tells me 0.025 amp hours. Yeah, that's all of the functions so far. Let's try the transient test next. So, I've set it to the transient mode with a pulse width of, on the positive side 100 milliseconds, on the negative side 100 milliseconds. And it switches between 3 and 1 amps alternately. And yeah, you can see it on the power supply. And that's how it looks on the scope. It's quite clean. It's alright. Rise time about 10 milliseconds and fall time about 11 milliseconds. Yeah. Let's decrease the time a little bit so it does it faster. Go to the menu. Hit enter. Let's go to 20 milliseconds on the high level and 20 milliseconds on the low level. Let's change the low level to, let's keep it at 1 amp, and the high level at, let's say, 5 amps, because this resistor gets quite hot. It's a 0.22 ohm. I don't want it to let it get too hot, so let's go back out, turn it on. Yeah, and as you can see, it does what it's supposed to. Rise time 8 milliseconds, 9, 10. Fall also. Yeah, it does what it's supposed to. So yeah. Alright, that's the functional tests of this unit of the ET5420 from EastTester. And yeah, as I said, I found some issues, like the not remembering where my cursor was on the value selection. Also, it doesn't have a channel follow mode, so if you need a 40 amp load, you can just put both channels in parallel. Unfortunately, you're gonna need the 40 amp model for this. And yeah, the other problem is the USB cable. It's not standard. Maybe we can find some serial port that's been hidden from the user and can be hacked in maybe. Also, well, the battery test constant resistance function did work somehow. It didn't for me the first time and the second time, but on camera it suddenly worked. It's weird. And if you can see, the display is a bit scratched. It's just the foil. Below it's alright. From the construction side, I mean, it's stable, but when I press on this side on the display, I see some waves in the display, so it rests on the front panel, so if it got hit by something really hard, it may break. Not sure about that. Yeah, and what else to say? I mean, it's a $200 unit. I think I paid $190 for it. You can get it for like $140 from China, but I didn't want to pay import fees and all that, so I got it off the Poland warehouse. And you can't really expect more for that price. I mean, it delivers a lot more than my Centro electronic load, which like goes for 250 upwards on eBay. That's yeah, and it doesn't do any better. So, and it has much less functions, and yeah, it's also not that precise. I mean, it has potentiometers, fine and coarse control, but 2-digit display and all that, and yeah, whatever. There's only one step left to do, and it's to take it apart. There we go. I haven't heard from the manufacturer about the PC software SCPI documentation and how to actually use the serial interface. If they answer me someday, I will put it in the comments. Yeah, looks like any other Chinese load. It has temperature protection on the MOSFETs. They seem really accessible. You can really easy replace them. It's just 3 solder spots and a screw. And fan. Some relays. It's like 2 identical boards, one for each channel, just flipped upside down. On the front panel we have a STM32, and I can't quite see it, it's a F103, quite big package. So interestingly, wires have been cut. This model has an optional, but I haven't seen any around so far, an optional RS232 or RS485 serial interface. I guess these are for the serial interfaces, and goes to the front panel, which I don't want to take out any further. To this small transceiver chip I will put the model number on the video. Also on this chip over here, it looks like CH340G, a serial to USB converter. Over there is a EEPROM, the STM, and some power supply stuff. Yeah, nothing major. And a port, I guess, for programming. Yeah, maybe someone can hack together a custom firmware for it. Well, let's take a close-up look on the boards. Some voltage regulators, the opto-isolated inputs. I guess both channels are isolated from each other. Certainly they are isolated from the mains ground, which is good. And 3 stages. It's using IRFP250N MOSFETs. Not sure if they are genuine, but yeah, they're readily available. 3 per channel, that's alright. And another STM32F103 in a smaller package, interestingly. I think they're communicating digitally to these boards over these opto-isolators. And yeah, this chip handles all the voodoo magic, and this chip is just for the front panel interface and control. But yeah, nothing to complain about. This transformer has 4 taps or 4 windings, one of which is this green cable, goes to the front panel. Then these 2 blue and black one with a center tapped. It's for the lower board, I guess. 2 yellow ones for the lower board, and the same goes for the upper board. So they're both isolated from each other through this transformer and the opto isolation. Yeah, I mean, it's alright. It's nothing to complain about. let's put it back together. So, what's my conclusion? Well, there's always someone who says, hey, Sigland or Rigol or Roden Schwartz or whatever is better, but you won't get them or their devices for 200 bucks. I mean, for 200 bucks, it's more than I expected, actually. I will buy it again if I need one. And yeah, there's nothing else to say about it. It does what it's supposed to, and just a few quirks, but nothing major. Yeah, I mean, but definitely recommended. Yeah. What do you think? Yeah, let me know if it's something for you. If the quality that I've shown in my teardown and function tests, if it's worth for you 200 bucks. If you need one, there are always alternatives like the KP184 and many other loads, and the cheap ones with a PC fan, and I mean they do all work and they all do their job. But yeah, I mean this one got a place on my bench, that's for sure. Alright, that's it. I'm Gamer Patty, and thanks for watching.